Welcome to our first webinar of EXQUISHEAT project. This webinar is also part of the webinar series Heat Big Implementing Industrial and District Heat Solutions. My name is Sabine Höfel and I'm a food engineer and have been working for over 25 years as a project manager at Food Processing Initiative, focusing on the transfer of innovation solutions to the industry. Today, I have the honor of moderating our first EXQUISHEAT workshop. First, I'd like to share some technical information with you. In this webinar, the cameras and microphones of the participants are off, but you will be able to write your questions in the chat. We will address the selection of these questions with the support of Francesca Tamburini from European Heat Pump Association. She's always in the background and back up the technical part in the moderated Q&A session. Please note that the webinar is recorded. Before we begin, I'd like to share a quick look at the participant structure. So who is in the room? We have registrants from around 40 countries worldwide, with a particularly strong participation from Germany, Belgium, Portugal, and Spain. But we are also pleased to welcome participants from outside the EU, including United States, India, New Zealand, Japan, and many more. So as you may see, that's a top topic. More than half of the participants are from the food and beverage industry. Among them, the main subsectors are beverage, dairy, sugar, oil, and fats. Thank you all. This shows just how important the topic is and motivates the EXQUISHEAT team to keep moving the project forward. Let's talk a short tour through the agenda. First part will be an overview of EXQUISHEAT project to give you some project facts, followed by a presentation on the opportunities offered by heat pumps, showcasing suggest full industrial heat pump deployments in dairy, spray, drying, and brewery operations will come next. Then the speakers will answer questions in the Q&A and at least wrap up of including next steps. Now it's time to introduce the first speakers.
Yes, thank you, Sabine. Do you hear me well? Yes. Good morning, everyone. Well. Good morning, everyone. Welcome to this workshop. My name is Audrey Meurice. I am working as project officer for company Veolia, and I am joined today with my colleague Elsie Hartjens, who is also working on EXQUISHEAT project. For those of you who don't know our company, so Veolia is an international company with its headquarters in Paris, but Elsie and I are working in Belgium for the business unit in Belux, and we are the coordinator of this project. Let me briefly introduce this project. So EXQUISHEAT, it's an European funded project who aims to accelerate the implementation of industrial heat pump in the food and beverage industry. As I mentioned we are the project coordinator, but we are very well supported by Dr. Jacob Energy Research, who is acting as technical coordinator. To understand why this project is important, we first need to look at the role of the heat in the industrial processes. So industrial processes require a large amount of heat, it's a fact, but this is especially true for the companies acting in the food and beverage industry because a lot of processes require indeed a lot of heat for production. And today you are facing strong pressure to reduce your CO2 emission. And so that's why industrial heat pump can be a promising solution, of course, to provide low carbon heat. However, the adoption of industrial heat pump in industry are still very limited today. Regarding our consumption, we have 9 partners from 6 different countries: Belgium, Germany, Poland, Australia, Spain, and Italy. Our project started in October 2025 and will run for 3 years to end in September 2028. We have a total budget of around 1.7 million euro, and it is funded by the European Union under the LIFE program. The goal of this project is to make it easier for companies to install industrial heat pump in the food and beverage sector. As you can see on this slide, the consumption includes different partners that cover the whole value chain. We have, by instance, research organization, technology providers, industry association, and also company working in installation and operation. And this diversity brings together different perspectives that help us to better understand how heat pump can be implemented in industry. Through this project, we have 4 main objectives. The first one is, of course, to analyze your own industrial processes in the food and beverage industry to be able to get some data who will allow us to develop standardized heat pump solution, to install them easier in industry. This project also aims to establish roundtable and discussion between new industry and our technology providers. And we also want to raise awareness and provide guidance for companies who are interested in this technology. In this project, we are not focusing on a specific subsector, but more on industrial processes. The first one is hot water generation, which is often used for cleaning equipment and for the sterilization. The second one is the pasteurization, where heat is used to ensure product quality and safety. The third one is the evaporation processes, for example, drying product or concentration. And the last one is cooling and refrigeration. Because these processes are very common into food and beverage industry, the solution developed in this project could be potentially replicated across the industry. That gives you a short overview of the project. Thank you for your attention, and I will now give the floor to Michael Strobel from Dr. Jacob Energy Research, who will present in more detail the opportunities offered by this project.
Yes, hello and good afternoon, everyone, also from my side. I'm Michael Strobel, Senior Project Manager at Dr. Jacob Energy Research. We're an international consultancy located in the area of Stuttgart in Germany, and we are dedicated to research and product development in the field of energy efficiency and renewable energies in general. I now have the pleasure to introduce you more about the topic on why industrial heat pumps matter, and also about the opportunities related to industrial heat pumps. First, I would like to start with some latest news. The EU is highly dependent on the import of fossil fuels. This is particularly natural gas, but also oil and crude oil. This was going more or less well for the last decades for Europe. However, especially the last 5 years showed the drawbacks of this dependency related to the Russian invasion in Ukraine, but also the latest news from the Middle East, from the Iran war, that not only the prices but also the delivery of fossil fuels is not secure, and we also don't know about the future. So that's why we must say that these are uncertain times for fossil fuels, but also uncertain future on this topic. And now you could say we leave the products and the systems running on natural gas, and within the next 10 to 15 years, we just switch to green gases. However, unfortunately, the market of those green gases, particularly hydrogen, but also biogas or other synthetic gases, is not developing or not strongly developing at the moment. So unfortunately, here the market is lagging behind. And also this is an uncertain future for the replacement of fossil fuels via green gases. So that's why the opportunity for electrification of processes is a great chance actually to switch off and to perform this fossil fuel phase out, as well as create redundancies and reliability in the operation of processes. Of course, it's not only relevant for process security and manufacturing security, but also a matter of environmental friendliness. The EU has set the climate target within the Green Deal to become climate neutral by 2050. This affects, of course, not only the industrial sector, but all mobility infrastructure, the construction sector, and the way we heat and cool buildings, for example. In general, this includes the phase out from fossil fuels, the expansion of renewable energy generation, such as from solar PV, wind, hydro, but also biomass. And additionally, to increase the energy efficiency and use untapped potential of waste heat. This again in the industrial sector particularly. Additional to the reduction of energy consumption and the expansion of renewable energy generation, there's also the topic of carbon capture and storage, whether it's carbon capture on-site or also direct air carbon capture. However, these technologies are still at an early stage and not yet widely available in the market. So yet we must focus on the fossil fuel phase out and the increase of energy efficiency. To achieve this, the European Union has also set the European Net Zero Industry Act. This Net Zero Industry Act has two objectives primarily: to increase the number and the share of net zero technologies manufacturers within the EU, as well as reducing or increasing the net zero technologies installation and implementations in the market in general. So there are 19 identified net zero technologies within this Industry Act, among others also heat pumps as a net zero technology. To have some numbers, by 2040, this Industry Act has set the target to achieve at least 40% of net zero technologies manufactured in the EU. This is very soon, since we are soon approaching summer 2026. So yes, this corresponds to urgent actions actually. Now, on industry heat pumps itself, for those who are not familiar with the technology of heat pumps. In general, heat pumps require electric energy as an driving energy source, and they pump the heat more or less from one temperature level to another temperature level. So heat source of a low temperature is required, and then the heat pump will generate or make use of this heat and pump it to a higher level, which is then applicable for a different process heat utilization. This heat, of course, should not be generated from natural gas or oil, but for example, a renewable heat, such as solar thermal, but also geothermal. There are still other solutions as a heat source. As described earlier, it's also about the waste heat, because this will directly increase the energy efficiency of the total site, since waste heat is also comparably free or very cost-efficient source of energies, which may require, for example, the installation of additional heat exchangers, but still on-site and industrial waste heat is a great potential to use. Another potential is also linking process cold and process heat, since via extracting heat from one low temperature heat source, we deliver cooling at the very same time. So this is a huge synergy and a huge potential for this technology and for your manufacturing processes. So industrial heat pumps have great potential. They are a net zero technology. It is fully in line with also political goals. However, what's the catch then in implementing industrial heat pumps, and why is it not showing off at the moment as it should be in the very best case? We identified already several challenges for the integration of heat pumps. First of all, it's a complex system, or more complex than the traditional state-of-the-art technologies, since it requires also additional piping, it requires this heat source. Also missing awareness considering the temperature range, for example, but also the conventional thinking of not seeing, for example, the potential of synergies within the processes and the sites. Additionally, technical challenges within a process, for example, when it comes to the heat transfer medium, whether additional piping may be required, but also economic aspects such as the first and upfront investment costs and the electricity costs, which is a major topic, for example, as we can see it also at the moment in Germany. And the last challenge to name here would also be the policy guidance to check about incentives, about funding schemes, that often it's not fully clear or it's not reliable depending on the current government, depending on the region and the nation. So these are several challenges we already identified. But this is also where our project, the project EXQUISHEAT, comes into action. As earlier described by my colleague Audrey, the project targets to develop standardized solutions and standardized integration schemes for heat pumps in the industry for specific processes. So these processes are the hot water generation, pasteurization, evaporation, but also refrigeration. For these systems, even though they are very unique for every company, the integrations schemes and integration processes should be replicable. And this is one point we focus on, to reduce the complexity and to facilitate the technical challenges within the processes. Another point is activities as we are doing today to raise awareness on the topic of industrial heat pumps and to unlock the conventional thinking. And also through these standardized integration schemes, we want to lower the investment costs, lower the complex installation schemes, and also deliver guidance for policymakers. At the very moment, the EXQUISHEAT project focuses on the activity of data collection. Since I already said it's about the development of standardized solutions for heat pump implementation and to facilitate the installation. We are currently collecting data and reviewing data on those identified processes. Within this data collection, we want to know what processes do you have on site in your company? How do you operate those processes? And also, at what temperature levels, at what mass flows and thermal loads do you operate these? So we can see and have the best picture of the common or most common process identification, and then develop the standardized solutions that are applicable for most processes and most sites. We very warmly welcome everyone to participate in this data collection. You can see here my email address. You will find a QR code later on in the slides as well. We collect those data all anonymously, and nothing will be shared with any third parties, but only for the course of the project. We will then consult each company individual for any potential benefits and advantages for you. So this is also one point and one aspect we are currently performing within the project. This would be it from my side for now, and I would like to hand over to Isabel.
Yep, thank you. And also a warm welcome from my side. I'm Isabel, I'm based in Germany, and I work for GEA. We are a large integrator of industrial systems for the food industry, and also some more than that, pharmaceutical industry, for example. And also in our portfolio, we do have refrigeration systems and heat pumps. I personally work with a group of experts where we are supporting the food and beverage industry in decarbonizing their processes. And we see that for most of those processes, in the end, heat pumps can play a major role for decarbonization. Today, I have two examples for you where we already today could apply heat pumps in a very successful way. And these examples shall also give you some insights in what is today already possible, and also some inspiration on why we think scaling heat pump technology for the food and beverage industry makes a lot of sense. So let's have a look into what we are doing. I think Michael already has done a very nice introduction in why actually heat pumps are so useful for the food and beverage industry. And what we see is today we often have steam-driven heating systems. And on the other hand, most of the systems are providing a temperature level that is quite high. And if you have a closer look at that, many processes within the food and beverage industry require less than 95 degrees Celsius. And even if they require higher temperatures, they still might be very useful for temperatures that heat pumps today can provide already. And I mean, for a heat pump application, you always also need a waste heat source. And this is actually something where also in food and beverage, refrigeration is often a huge unused waste heat potential. You normally have a temperature of 35 degrees Celsius, which you cannot directly use in the processes, but with the help of heat pumps, you can suddenly untap a huge waste heat potential for your processes. I think also a positive message on that is that in today's available technology, there's a lot of possibilities to also retrofit into existing processes. That's a concern that often we hear from our customers that we are helping with these type of projects. Is that something that I can only apply when I build a new factory? Is that not complex to in the end switch my existing steam network to hot water? And we can see that today's technology also allows you to apply this type of technology in an existing factory. So let me give you also some insights in the bigger picture of decarbonization, also put in perspective why we believe that heat pumps play such a crucial role. When we're looking in factories, we often have 4 major steps of decarbonization. The first one is normally around process optimizations, potentially retrofits of technology. This is normally something where at least 10 to 15%, in some sites even more, should be possible. So that's one first essential step in decarbonization. And then you would normally try to recover as much waste heat at the same temperature level that you also require in the process, directly integrate that. So that can be direct integration of networks then And then actually you will face a situation where you have still unused, unutilized waste heat streams. And I mentioned refrigeration. There can be others like hot water sources, not hot water, wastewater sources, for example. So there's quite a few opportunities normally on lower temperature waste heat that we can still utilize for the processes. And this is where this entire heat pump topic makes so much sense, because that is a heat source that is normally not used yet in your process optimization. And I will show you in the two examples that I have for you that this can play a significant role in your roadmap to decarbonization. And then the last step would be, if you have done all the other steps, there still might be a remaining left, and then you might want to replace your traditional fossil fuel steam systems by other technologies. You know? But we see that heat pumps, I would say, have one of the biggest levers in that entire story that you can have. So it's, in my opinion, very crucial technology for decarbonization. So let's have a look at two specific examples. I think that might, for most of you, be interesting. I would like to firstly show you one project that my colleague and team member Riccardo Bergamini has successfully implemented together with ALA. And we are very proud that we are also allowed to share this results with you. And I think that's quite a good story to see that also in more technical, challenging environments, you can have a successful implementation of heat pumps. So what we have done here is actually we looked into the challenge of decarbonizing spray drying. And I think this is because of the high temperature level that you require, but also of the sensitivity of the process, quite a challenging one. And we've developed that in a partnership here for this project. And let me show you what actually has been done here. So what you can see is a tailor-made heating system for spray dryers that is based on a high temperature heat pump. And that is, in this case, a CO2 transcritical heat pump. And the system generates 130 degrees Celsius, which is then used to preheat the main air of the dryer before the conventional heater, which is in this case a combination of steam and electrical heater. But you can see on the left bottom side, the system not only delivers high temperature heat, at the same time it provides also low temperature cooling in the form of ice water at less than 3 degrees Celsius. And the system here that we are seeing has a nominal heating capacity of 900 kilowatts and a total system COP of approximately 3.6. So when you look at the impact what such a system can actually create, it translates into abating approximately 1,500 tons of CO2 per year, and that is saving around 59% reduction in natural gas for the heating of the primary air that you would see in the top line of that process flow. So additionally, it has also some benefits, as this is an entire system integration. Thanks to the production of the ice water, we can also reduce the load of the existing chilling system, for example, which is achieving an extra electricity saving, and moreover, the system also reduces load and noise on the cooling towers. And that was in that project also a nice additional benefit that was created. So let's have a look a bit more also about how that was made possible. You can see here on that 3D model that this is a compact system, and it was actually a retrofit of an existing spray dryer. And I think this is especially for those of you who are thinking about how to implement such solutions in your existing processes. I think good to see how that can also be implemented. And installation did not require any additional plant shutdowns, so it had to be carried out in the normal maintenance window of the plant. And given that the system could fit into the plant, the most important thing was also to ensure that we have a complete stable production. And I would show you that now in the next following slides. And I would say that is in general in food and beverage industry a very important one, that all type of these retrofit solutions, you not only think about what you can impact, how you can impact your sustainability performance, but it needs to go hand in hand in the end with your production requirements. And that is why, in my opinion, system integration is such a key as well. So let's have a look at that. So the system that was a first of its kind installation, and we could prove a couple of important points. I mean, firstly, what you can see on the top line is that, and that is recorded data, by the way, of the implemented system that we also had for data management here. So over the dryer run, you can say that there's stable temperatures, and even the temperature level was reaching a little bit more higher temperature than promised. And it's important that this dryer temperature is at the end stable over the entire production process. And let me show you some more details on that. So that is also true for the startup and also ramp down of the, or shutdown of the plant. So what you can see is how the air temperature increases gradually when the heat pump is starting up. And this is here done in actually just 14 minutes, and this is less as the normal startup time of the dryer. So in the same way, you can also see that the shutdown is a very controlled process. And I mean, this is quite crucial to ensure that the product quality is in the end also given. Also, I mean, in production, you can always have some unforeseen in the end events. It was also very important here to prove that we could have a system integration that is actually ensuring stable production conditions. And you can see that this was here done in a way that the system, both in unforeseen shutdowns of the system, but also in the next page, you can see here that this is actually both shutdown and actually also start up again stable temperatures at the production site. So what are the key learnings of that project? I think there are 4 main points. Firstly, I think it's very important to understand the vision also of a production site, because then you can in the end also design a solution that is fitting commercially, production-wise, and also from a maintenance perspective or from an installation perspective, perfectly the needs of the site. And in our opinion, it's very important to also see the bigger picture of the production site. So that means normally the entire production process has a huge influence. So this is really important to have a holistic perspective on that. And this also is true for the integration. So the integration is crucial. Production must be ensured at any time. So I showed you how also unforeseeable events might potentially influence production, and that is crucial to have also a control on the heat pump or a backup system that can cover that and ensure in the end reliable production of the system to all time. So, and last but not least, I think for that project, my colleague put it here in nice words: be careful, not fearful. I think this is also something that we discuss a lot when it comes to these type of projects. For many sites, it's new technology, it's exciting, but it's also sometimes coming with a certain fear. And I think we can here proudly say that this was really turning into a success story. And I think it's absolutely worth to explore these technologies also on different temperature levels for your applications. So as a second example, I would also like to show you another one, because I mean, my colleagues were talking before about different type of typical applications that we see in food and beverage industry, and while spray drying is certainly one of these more energy intensive processes in the dairy industry, we see that a lot of factories require in the end hot water, or pasteurization is also a big topic. And this is why I also show you now an example what we have done with the ammonia heat pump in a brewery. And I would say some of the learnings that we had from that spray dryer projects are also true here. So the one is the total system integration, which is very key. But second, I think what is here also key is that operation is extremely important, especially if you think about a pasteurizer. I mean, that has direct impact on the product quality. So we need to ensure that the integration is done in a way that this is ensured at any point of time. So the system that is here installed is actually also using the refrigeration system for generating the waste heat. And actually, we are providing here hot water in a 90 degrees Celsius network for multiple applications. And let me show you a bit more about the brewing process, because that's, I think, also key for a lot of other projects as well. When you analyze the user structure, you will see that a majority of the users actually do not require 8 bar of steam. but most of the uses actually are below 100 degrees Celsius. Or in some other projects, you can also see that there might be other temperature levels, but there's a lot of opportunities, yeah. And also here in breweries, we had here a typical waste heat temperature of 35 degrees Celsius, and that's very suitable for ammonia heat pumps. And today, proven technology can provide temperature lifts up to 95 degrees Celsius with very favorable total performance of the heat pumps. Key is here a robust design, and I'm especially talking here about the need of buffer tanks, because you normally see that in these operations that there's a lot of unit operations, and that make it also kind of challenging, so that you have to balance the available waste heat with the heat requirements, and this is especially requiring attention in designing a proper buffer system here in between. So to summarize that, in this project, we could save an estimate of 45% of the gas that is formerly used for steam generation. So we can see, I mean, if you think about 45%, that's nearly half of the total thermal energy of a site that you can provide from waste heat. I mean, that has really a significant impact on actually your carbon performance. And so therefore, I think this is a very good use case to show how important the entire use of heat pumps can be in decarbonizing process heat. Okay, so, and with that, I mean, I'm at the end of my short time slot. I think there's a lot of potential technical questions where you would like to deep dive a bit more in detail. I have also put my contact details here, so we are very happy to catch up with you on a more detailed technical session. I think that would be a bit too much for today's session, but if you want to know more about any specific technical details, feel free to reach out. And yeah, thank you.
Yeah, thank you so much, Isabel, for the insights which demonstrated really the potential of heat pumps. And thanks to the other speakers as well. Next topic will be our question and answer session. And therefore, I'd like to welcome all the speakers. I would like to say thanks to everyone who joined the chat. The chat is still open, and we will wrap up a few of the questions. Some are very detailed questions to Isabel. Some are more broad, and let me hand over to Francesca for the first question to the audience. Francesca, what kind of question is in the chat that fits most of the participants from the Q&A session?
So I see different questions actually for the last presentation of Isabel. So maybe we can start from it, if it's okay, and then we go back to Michael. Well, there is a first question. I will read it for you, Isabel. Do you, from Dr. Rudolf Michel, sorry for the wrong pronunciation. Do you also provide an accredited energy consultant to request financial subsidy from German government? I don't know if you can reply to this question.
Yeah. So we do have indeed some experts that are providing energy consulting or consulting work for the industry. What we don't have is any financial subsidies in-house, but we're working with partners actually here on that. That is because we are working mainly international, and this is why we are choosing to work with a partner here that is always up to date with the latest subsidies. So I hope that answers the question.
Thank you. I will go on with another one. Hi, Isabel. Thank you for the presentation from Kalin Tasnadi. What was the average temperature difference uplift delivered by the heat pump on the first presented case study?
So I have to double check that data, to be honest. So I will actually provide you that information in the chat afterwards, because I will have to open a spreadsheet and look that up. But I'll give you an answer in the chat later.
Maybe we can read just another one still for you, coming from Marco, connected to the Arla case study. Is asking if will Arla copy-paste this solution through their other factories, and what is the electricity cost at site that implemented industrial heat pump?
Yeah, I think you will certainly understand that we will not have all the transparencies of investment decisions of these groups. But I mean, in general, this is a technology, as you can see, that we are also allowed to talk about. So it is applied very successfully. We are also in the entire dairy factory looking in a lot of different, actually, other opportunities for this type of technology. So I would say it is definitely something where we believe that has a scaling potential in many spray drying factories. I have to say it's also not the only technology that we apply in dairy industry. So depending on in the end temperatures, also the entire system integration, you might have different solutions that suit. But we do believe that this is absolutely scaling technology, and it's sometimes very site specific also which technology is the best one for you. We're happy to also investigate that more in detail. Might be also a combination, for example, of ammonia heat pump, hot water system, and transcritical CO2 heat pump. So that really depends a bit on the system integration that you also require. Okay, and there's another question that maybe I can link also to that, and that is on the payback periods. And this is also something that is very hard to generically answer, because that's something that is very strongly related also to your location. We see that for most European factories, we can really foresee a positive business case. And that is still depending on the size of your system, the waste heat temperature, the maximum temperature lift, and some other parameters. But if you're interested for a specific application, we can also help you to understand the financial metrics on that. So if you have a specific case in mind, please reach out. But I can tell you most of the projects that we see will only be an investment case in case that there's a positive business case. Yeah, so I think this is also the good news. There are definitely positive business cases for these type of applications.
Francesca, I would like to take up the question from Rudolf Michel for Michael and Uli too, because the question of if we request a financial subsidy from German government, or if we know particularly funding pots, that might be also an answer that could be given by Michael and Uli. And it's also part of the project, so maybe you would like to enter on this question too.
Yes. So first of all, within the project, we also do screen in the driving factors, but also in the barriers on the different funding schemes. When it comes to individual consultancy, this is not directly part of the project itself, but feel free to reach out on this as well. Because this of course depends a lot on the individual use case, on the size and the capacity of the installation. So within the project, we won't provide this consultancy, but we do screen the potential of the funding and the incentives, and it's part of our work in the project. But yeah, feel free to reach out on this to us.
Thank you, Michael, for the answer. Maybe Francesca, I have a few more questions, and then you get back to the chat. Okay.
Yes, sure.
The next question is from Francisco Calindro. Are there any economic benefits for the companies that share this information with the project? He dropped this question after your presentation, Michael, so maybe the answer is on your side.
Sorry. Yes. It's of course it depends again on the specific country, on your electricity prices you pay with your grid supplier or electricity supplier, which is again dependent on the size of the company, and also whether it's part of any current national subsidies. In the long term, we foresee definitely this economic benefits for each individual company. Considering also, which was not yet included in my slides, for example, because it's again another field, for example, the taxing on CO2, which is going to increase, planned by the European Commission, to also again make net zero technologies more attractive. Of course, we don't know yet the development of electricity price, but also the price of natural gas. So economic benefits and payback periods, as also Isabel already described, is dependent on the individual use case.
Sorry, maybe I was not precise enough, but I guess he wanted to know if he delivered for the EXQUISHEAT project some data, if there are some economic benefits for the companies who deliver the data. That was a question. Will you answer?
Of course, yes.
Or should I? It's very easy. Sorry.
So any company that is cooperating with us in this data collection to identify these most common process definitions, we will provide an estimation on future savings in natural gas, future savings compared in future economic savings with the data you provide. Of course, we won't be available or won't have the potential to describe in detail, for example, the installation costs, but we will provide those initial data, of course, to give a first feedback on the suitability and the potential.
Thank you so much, Michael. I have one more. I think it's a tough cookie, but maybe Isabel can answer to it. What do you think? What basic requirements should a process have in order to make the installation of a heat pump as straightforward as possible?
That's actually a very good question, I have to say. I mean, there's a couple of things that I feel from the cases that we are investigating and where we see positive business cases. And the first one is actually the temperature level of the users that you would like to connect. I think there's a general statement that is true for every factory, and that is the lower the temperature lift, the better the performance of a heat pump, right? Because you normally have a waste heat source that you cannot directly integrate in the process. So this means you, of course, have a temperature lift that you have to do. If you can identify, for example, users at a 60 degrees Celsius network or a 90 degrees Celsius network, and additionally already have an existing hot water network, that makes the business case extremely positive, because the modifications are actually not that complicated. While if you're having 600 degrees Celsius process somewhere for burning some fatty substances or something like that, the lift will never come to a commercial business case, or even not be technically possible in this case. Yeah. So this means also for like 8-bar applications where you really need that temperature at the heating surface, heat pumps might not necessarily be the best technology to use. Yeah. There's more, I would say, high temperature applications, but you should keep in mind that the higher the lift, the less performance you will get out of the, in the end, waste heat utilization. So that's, for example, the first, I would say, area where I would really look into. And then also from an integration perspective, what we see is in existing brownfield facilities, you will face challenges if you have complex modifications of your users. So if you have a very old machine, for example, that has a heat exchanger that you need to change, and I've seen some machines that are 30 years old that you would perfectly suit, like a tunnel pasteurizer, for example, in beverage production. Yeah. So you should really look into, is that retrofit commercially and also maybe technically something that you can do, and that also is guaranteed that this is a success. Yeah. So this, I think, is a very crucial one that you should keep in mind to choose the right users. And then a generic second topic that I think is really important is, I mentioned before, in the brewery, sometimes you have a challenge of users that are batch oriented. So that means you have a resulting very spiky load profile. And one thing a heat pump system normally does not like is to ramp up and ramp down very quickly. So that means either you find a possibility to buffer that. And I think there was also a question in the chat on buffers. So in my opinion, they play a very crucial role in such heat pump systems. But that also means if you have a very constant user, then this is certainly a good application of a heat pump. And normally it will not be an insulated single user, but it will be a group of users that you are connecting. And if they are not spread across your factory, but close by for a connecting network, I think that's for sure also a benefit. Yeah. So I hope that gives you some indications where to look for when you're going with heat pump applications. Yeah.
Yeah, thank you very much, Michael. In the project, I guess there's also a topic to give the companies some easy tools at hand. Might this be part of 5 questions to answer to know if heat pump might be versus to implement what Isabel already mentioned?
Yes. So the EXQUISHEAT project, as it was earlier presented, is now running for about half a year, and the project will run 2.5 years more. And towards the end of the project, so not this year, but hopefully next year, we will provide an online tool on the project website, which will be a first indication to fill some numbers on your process. For example, the temperature of the waste heat, if you have waste heat available, or the temperature that is required for your process, whether it's pasteurization and so on. And this way, we want to give a first indication on the potential of a heat pump, so you can quickly check your own whether your own process already suits very well a heat pump, or what needs to be integrated, for example, additional heat exchangers and so on. One point that was highlighted by Isabel is really the integration of the heat pump installation into existing processes and into existing actions, such as you are already replacing and updating a specific process, then you really must check for the opportunity for heat pump integration. Otherwise, you may miss out opportunities in here. But this will be delivered by the project later on, after the collection of data, the analysis, and also these development of standardized solutions.
Thank you so much. Maybe Francesca, so you have some new questions in the chat that you'd like to share?
There is one question from Tony Penano. Is there a lot of need for steam above 6 bar in the food and beverage processes? I ask because our first version of a heat pump that produces steam directly produces max 6 bar steam. Up heat solution if somebody is interested. Thanks, Tony. Who wants to take it?
I can, Michael, or would you like to, or shall I?
Okay. I think it's best for you, Isabel.
Okay. Well, I mean, I think the food and beverage industry is a very big and generic word for industry. Yeah. So I think it really depends on the application. What we see, if you have liquid processing, dairy, and so on, you normally have a majority of the networks today with 8 bar steam. And not necessarily because you need that temperature, but it was in former times just a very good and efficient way to transport energy from the boiler house to the users, and also high temperatures require smaller heat exchangers and networks. So I would say, yes, there is a bit of need. If you look in the beverage industry, for example, I would see not a lot of need for really high temperatures, so above 6 bar. But there's also, I can reference here to a couple of also scientific literature or scientific papers. So there's a very nice one that is actually showing the potential of high temperature heat pumps by Andrew Marina, for example. So there's a couple of that gives you a bit of an overview. So the temperature requirements will in the end be interesting then for that application. What I mentioned, what I see more critical is if you're going beyond 6 bar. I mean, as mentioned, you need to have a waste heat temperature that you are using, and you have to go up to a very high temperature then when you're going above 6 bar. And we see that at least with the commercial available technologies that we see today, there's in very few cases applications that are, in my opinion, commercially already feasible at that higher temperature lift. Yeah. So yes, there's potential need for some applications. A lot of a lot of processes don't require that high temperature needs.
Thank you, Isabel. There is another question, still technical, so maybe still for you. What capacity of an industrial heat pump will have the biggest market share in the food industry?
That's hard for me to answer the question. I mean, there's, as mentioned, there's scientific literature on the potentials. Yeah, so I think this is a first indication. Maybe what we see today, that a majority of the solutions that we see are still below 95 degrees Celsius. And there are some more upcoming ones for 120 or even a bit above that. But at the moment, we see, I would say, a majority of the share below 95 degrees Celsius. If that remains like this, I have no clue, to be honest.
Yeah, thank you so much. I think we are a lot before the time, but the discussion is quite good, and the chat is running empty, so a lot of the questions are answered already.
Yes, there are also questions in the Q&A section. Maybe in the time Sabine or Francesca check on this, I have also one question for Isabel on the 2 case studies you presented. Since, of course, for every decision maker and manager in the food and industry sector, the quality of the product is most important, and also to reduce the interruption of processes. So, for example, in those 2 use cases, how much time do you consider for the planning and also for the construction and installation and commissioning?
Yeah, that's a very crucial and important question. I mean, what we see is that has to have a crucial role also in that entire project planning process. What our experience is, the closer we work together with the site team, the more we can reduce the time of or downtime of the plant. So I think I mentioned that for the first, or let me maybe start with the second example. I mean, for the brewery example, I mean, there's really a minimum interruption of operations only, and we even have one beverage producer example lately commissioned where we, so that was not one of the examples I presented, but I liked that a lot because there we could actually switch 11 users from steam to hot water, and we managed to even not interrupt the production at all. Yeah. But that required a lot of planning, and that required also a lot of, in the end, discussions with the site team, how to implement that, when is their maintenance window, where they're anyhow doing shutting down operations and doing maintenance on their site. But it is crucial because in the end, every minute that you shut down your plant, you will lose money. Yeah, so this is very important. I would say it's unfortunately also not a generically, or a question that you can answer completely generically. Yes, it will also require a closer look in what changes have to be done on the system. But I think the good news is there are examples where there was even 0 shutdown time for the plant.
What I like to do was that I like to integrate Elsie and Audrey as well, and therefore I had a question to you, Audrey and Elsie. You are the lead as Veolia. What was the key factor that you promoted that promoted you to explore this topic of heat pumps?
Well, for us, Veolia, electrifying the business process in food and beverage is one of our bosses. So we are really looking into how to implement this and make feasible business cases. So this is why for us, this project is very important, and we as Veolia support this and want to be the coordinator of it.
Okay. Yeah, that's the point. It's a good one. I think it's also a point for all the partners that are in the project, as you already mentioned, the other partners, also for EFA, the European Heat Pump Association, that also supports the project. I opened up the Q&A, and there is a question that has no answer now. Any examples of integration of heat pumps as a service inside factories? For example, third parties that pays CapEx and collects fee per unit of heat provided. This is a question from Josh Gardland.
I can quickly feedback on this. That I myself am not aware of any such examples. However, it's a very interesting business model also, similar to ESCO, of course. But me myself, I'm not aware of it. I don't know if Isabel or the colleagues from Veolia know about this.
This is indeed a way of working that often is done within Veolia. So depending on the way of collaboration with our clients, sometimes we do the investments and we guarantee savings in their business process, or they do the investments and we get paid as an installer of the project. So this kind of collaboration is indeed a possibility with heat pumps also. And we are already doing that within Veolia.
Okay. And Gea?
So you ask me, Sabine? Yeah.
Sorry, and Gea, Isabel, sorry.
Yeah,
and
okay,
Gea?
sorry. Yeah, it's indeed a discussion that we hear a lot in the industry. I think there's definitely as a service business models discussed for these type of applications. There might be some challenges depending on production side. Not every food and beverage manufacturer wants somebody else to operate their plant. That's a discussion we hear a lot. But it is indeed a very interesting business model, and we hear that discussion a lot. We as GEA, I mean, we are more equipment provider in this case, or not offering that from GEA, but we are also working with partners on these type of models. So it's definitely a discussion that is relevant for the industry at the moment, and we see more and more of these discussions recently.
Okay, and give the floor for our last question round. If anybody from the participants has a question, if not, I would like to hand over to the next topic.
I think, sorry, there was one question we didn't cover yet from Adam Dixon on the temperature of waste heat input. The higher the temperature and the higher the desired temperature as an output of the heat pump, it's always the closer those two temperature ranges and the temperature output for your process you want to supply to, and your industrial waste heat temperature, the closer they are, the more efficient is the heat pump. That's the case for every installation, every heat pump. So if you have an outlet temperature, for example, of only 60 to 70 degrees, I would say 40 to 50 degrees waste heat already is sufficient. But if you want to reach higher temperature and steam generation, yeah, the higher the waste heat temperature has to be. But there's, from my point of view, no direct thumb of rule. I don't know for you, Isabel, whether you say you need a dedicated minimum waste heat temperature, if there is any.
Yeah, there's certainly, depending on the heat pump model that we choose, different requirements on heat that we have as an inlet. I mean, that's just the design of the different models of heat pumps that we, for example, manufacture. As mentioned, I think 35 degrees Celsius of the waste heat source for industrial heat pumps for refrigeration is a very typical one, but we can vary here as well. And you rightly mentioned that that depends very much also on yeah, what's your target temperature. So there's different possibilities for sure on the temperature level, and you might also vary on the technology that you're applying for this, depending on the temperature needs. Yeah.
There is just last question in the chat. If we have a last 1-2 minutes, maybe just for Isabel. For it as a service model, do you offer extended warranties for heat pumps for the period of the contract?
So firstly, I think just to get that right, I mean, we personally as GEA do not offer at this point of time this as a service model. So we would supply the equipment. I mean, we do have different possibilities in our service contracts regarding, in the end, service of our machines. But I'm honestly not aware of any extended warranty periods. But I would have to double check that with our team.
Thank you so much. Thanks for the questions. Thanks to the group to the answers. If you have any further questions, please contact the speakers and the team from EXQUISHEAT. They will be happy to answer your questions after this workshop. And this will also be not the last workshop. It's just the beginning of a workshop series. So there will be more time to come with questions to the team of EXQUISHEAT. Next step, I would like to give the floor to Uli Jakob, Dr. Uli, or Professor Dr. Uli Jakob. He is the Manager Director at Dr. Jacobi Energy Research and Technical Coordinator at EXQUISHEAT. And he's also Professor at the Stuttgart Technical University of Applied Science. Please, Uli, share the key takeaways with us.
Yeah, thanks, Sabine. Also, warm welcome from my side here at the end of this first workshop of the EXQUISHEAT project. I just want to sum up all the different aspects which have been presented by the different speakers and also has been discussed in the Q&A session through the different questions coming from the chat, and give you just somehow a summary what you probably could take away from this webinar, and which also probably leads you to a further collaboration with us here in the project also in the future. So first of all, I think it's quite important to say that heat pumps, especially also for the food and beverage sector, are just not only a necessary technology which is somehow used to be for environmental issues, but also, as we have seen from the different best practices from Isabel, that those kind of use of this technology is also from a business point of view quite interesting. So it's not only about the environmental issue, it's also that it's nowadays also business-wise quite interesting. Of course, it has to be fitted with the different projects, with the different boundary conditions, but that's something where, as we as a project also want to have some insight from you, as Michael was already saying, collecting data to, at the end, give you some advice for standardized solutions for the beverage and food sector. So decarbonization through electrification, as seen before, is a key also for these industrial heat pumps as a core technology now. And I think that's quite important because of the decarbonization of the industry, to have a close look now into this kind of technologies, which are available, as we've seen, ammonia heat pumps, CO2 heat pumps. There are also others like propane and so on, which of course have different kind of boundary conditions. And more important is, of course, that we have different challenges, as we have seen and have heard from Isabel and other colleagues and speakers, especially if it comes to the implementation, thinking about different batch processes, load profiles, and so on, which is not that easy like for conventional systems in the past, that if you want to use heat pumps, that you do it in the right manner. And with that, the EXQUISHEAT project like to help you in the facilitation through a so-kind standardization process to probably find out the common solutions for the food and beverage sector, which really helps now then later on to push this technology in a broader range in installations in the field. And so there's a progress in the development also in this kind of technology, but of course, especially if you think about different applications and also the implementation, there's a lot of to do still, and that's why we also have this kind of project. To sum up, especially the different aspects coming from the showcases presented by Isabel, you have seen that different technical feasibilities already demonstrated. There's a good feedback also from the customer. And I think that's also important that we are allowed to show this kind of examples now also here in the project, because that also shows that the customers are satisfied with the technology. They are willing to invest in such a technology also in the future, maybe to replicate it also to other sites, as it was also asked in one of the questions here in the chat. So I think that's really important to see that is from the showcases now that we have really something which is not only just in a development phase and as a prototype. No, there are real products available and which are now coming into the food and beverage sector. And as said by Isabel, you have to have a clear vision and a roadmap, especially to take the first steps together with the companies which are providing such technologies. And GEA is one example. Of course, there are others. We have also seen that in the chat. And so there are more coming as well, and only help us to develop this market here for the food and beverage sector to be decarbonized. Yeah, there should be a holistic view on the overall topic, on the side, on the processes, to make it more easy at the end to integrate such technologies and to find the right solution, which is then also fitting in the different production timelines. So not to shut down all your production, because that's not feasible, of course. And so this is really important to have a close look on that. And that's where also consulting work is somehow feeding in, and which is important to do the right heat pump design at the end and the selection of different kind of refrigerants, as we have seen before on ammonia, CO2, or also others, to have a specific use case on the temperatures needed, and which then allows you to have a best practice, the best business case at the end for your facility, for your production site. Yeah, what are the next steps? As said before by the colleagues, this project has probably recently started. So this year, we will analyze different processes with the data which we are now collecting. We want to define a common process for different kind of aspects, of course, within the food and beverage sector. In total, 4 kind of processes are identified in general already. You can have a deeper look on that also on our website. We will follow up this also next year in 2027 to develop then standardized solutions and implementation guidelines, which should allow you as a company owner or a facility manager to easily integrate now and to ask for such solutions to decarbonize your processes. I think that's really important, because that's the main outcome now later on in this project EXQUISHEAT, which should help you really to overcome the different barriers which are nowadays hindering you to think about why not use now heat pumps for your future production lines. Yeah, as said, we are collecting data, so that's quite important that you probably reach out also to us as a project. There are different possibilities. Michael Strobel was saying already that you can contact him by our email. You can also now scan this QR code, which will be also available later on, of course, in the slides which we are sharing. So it's important that if someone of you is interested to be part of the EXQUISHEAT journey, then you can just easily write us or using this QR code, which leads you directly to your email program, and then you can send us a request to get in contact with Michael and the other colleagues, and also to get some more feedback also on the different aspects which were shown today already in the project. And moreover, as this is a first webinar, we also have prepared a feedback form. So that's the right one, QR code, which allows you to give us some feedback on the different topics you have seen today from the speakers, but also some common questions which probably allow us also to improve our webinars for the future, maybe new topics which are your interest and so on. So please use those 2 QR codes. This will be available also later on, and you can send the feedbacks or your inquiries also then in the future. So, and I think that's important to stay in contact, to exchange ideas, and with that to decarbonize your sector, because I think that's quite important. And the heat pump technology is a core technology for that. And with that, hope to see you also in one of the future webinars. And with that, I want to hand back to Sabine at the end of this wrap up and next steps for the future work which we will do in the EXQUISHEAT project.
Thank you so much, Uli, and thank you for your wrap up of the key takeaways. Yeah, dear participants, dear speakers, we are now coming to an end of this first webinar. And thank you very much for joining. If you have found this information useful and want to stay updated with the rest of the project activities, please follow us on website, LinkedIn, X, YouTube. That was the first series of the. This was the first workshop of a series of workshops, as already mentioned. The next will take place in the second half of this year. You're cordially invited to attend. Please remember to fill in the questionnaire, because with your support we can tailor our offerings to your needs. If you'd like to receive regularly updates, please sign up for our newsletter. And this is not my last slide, because I want to say thank you very much, and let's stay in touch.